Welcome to today's class. I'm glad you're there. Now we have an electricity question to solve. Of course, from what we have on the board, we have a circuit diagram. And from here, the question they ask here is calculate 1, the total resistance. 2, total resistance when the switch is closed. Of course, this is the switch. This is an open circuit. Number 3, potential difference across the 2 ohm resistor. And finally, the total current flowing in the circuit when the switch is closed. Solution. Number 1, total resistance. And of course, from here, looking at this is an open circuit. Now, when this circuit is open, that means this place is not functional. When I have this and this, in other words, we have 2 and 3. And these 2 and 3 are connected in series. So we have total resistors in series equals R1 plus R2. Now, resistance in series is equal to R1, we can have 2 plus R2. Any of them, we can take this one first, we can take this one first. Doesn't matter. So R2, we take 3. Therefore, total resistors in series is equal to 5 ohms. Number 2, total resistance when the switch is closed. Now, if we close this circuit, this one becomes functional. We now have this and this. So, in other words, once we close it, this one will now be in parallel and this one will be in series. So, let us resolve these ones in parallel. So, we have resistors in parallel. Of course, the resistors in parallel will give us inverse of Rp equals 1 over the first one plus 1 over the second one, 6, which will give us, and of course, the LCM of 3 and 6 is 6. 3 into 6, 2. 2 times 1, 2 plus 6 into 6, 1. 1 times 1, 1, which will give us 3 over 6. And 3 over 6 will give us 3 here, 1 here, and then 2 here. Therefore, we can say that resistors in parallel is 1 over 2. In other words, if we make Rp the subject, Rp will give us 2. Total resistors in parallel is 2 ohm. Now, for us to get the resistance in the circuit, we include this. Therefore, we have total resistor Tr equals resistors in series plus resistors in parallel, which will give us that in series is 5 plus that in series, please, which is 2. The resistor in series is 2. 2 plus the one in parallel. Of course, if we resolve it, this is the answer we have. So 2 plus 2, which will give us 4 ohms as the total resistor in the circuit. Now we have the third question. Potential difference across the 2 ohm resistor. In other words, the potential difference across the 2 ohm resistor is this. We can represent it as V2. So we're looking for V2. Now, since we don't know the V2, and from Ohm's law, we have that V is equal to II. Now, we have V in the circuit, which is 12 volts. So V is equal to 12 volts. Now, the resistor, the R, the total resistor there in the entire circuit, which is RT, total resistor, is equal to 4 ohms. We don't have the current flowing. There is no current flowing. In other words, before we get our current flowing, and I want you to also notice that the current flowing, this one is exclusive. So because of that, if you want to find the current flowing, saying this one is exclusive, we'll have current flowing here. Now, the R we are going to use is the one in series, which is 5. So the total resistor in series here is what we are going to use, which is 5 ohm. Now, we want to find the current flowing in this circuit, or current recorded by the ammeter. So current is equal to V all over R from Ohm's law. So current in the circuit will give us V equals 12 all over the resistors there, which is 5. And 12 over 5 will give us, by calculation, 12 over 5 will give us 2.4 ampere. So the current flowing in this circuit now, remember this one is exclusive, is 2.4 ampere. Now, for us to get our, we have gotten current flowing here, and sorry, potential difference in the entire circuit, and then current flowing here. With these two pieces of information, we can get the potential difference across the 2 ohm resistor, which will give us V2, and of course we have V2 here. V2 is equal to current in the entire circuit times R2, and of course R2 is that 2 ohm. So V2 is equal to current in the entire circuit 2.4 times R2, which is 2. Therefore, the voltage drop across that 2 ohm resistor is 4.8 volts, which is 2 times 4.8 volts. And then finally, we have number 4. Total current flowing in the circuit when the switch is closed. Now, current flowing in the circuit when the switch is closed. If you now close this, the resistor we use is the entire resistor. So, which will give us R is equal to, which is we are using the R total now. R is equal to 4 ohms. Then I equals the current in the circuit is what we are looking for. Now V is equal to 12 volts. In other words, we can have current in the entire circuit as V all over R, which will give us the V then is 12 and R now, which is the combination of the one in series and the one in parallel, which is 4. So 12 over 4 will give us 3 ampere. Therefore, the current flowing in the entire circuit is 3 ampere, while that flowing when the circuit is not complete, the one flowing here is equal to 2.4 ampere. In other words, we can conclude that by introduction of this one, which is closing this circuit, the current increased by maybe the factor. If you want to know the factor, it will now be 3 minus 2.4, which is 0.6. So by a factor of 0.6 ampere, the current is increased. All right. Thank you very much. Please make sure you go through this and share this video for others to get this information. Do not keep this information to yourself. Don't forget to hit that like button. Thank you very much.